Welcome to Otisam Mathematics. I am on the series Logarithm. In this video, I'm going to look at equations involving logarithm. So let's start. Equations involving logarithms. Such equation can be transformed to linear or quadratic equation or simultaneous equation. So what I mean is, if you have equation involving logarithm, you can transform it to linear, you can transform it to quadratic or simultaneous equation. So with this video, you'll be looking at linear and then quadratic, how logarithm equation is transformed to linear and then quadratic. To solve logarithm equation, we use the following concept. The first one is by the definition that if log of p to the base a is equal to k, then we can transform it to indices, which is p is equal to a to the power k, as by definition of log. Or the second one, if log x to the base a is equal to log y to the base a, the bases are the same, then we can equate the numbers. Now this concept is expressing both sides as a single log. So when you have the logarithm equations, one in each side of the equal sign, you express them as a single logarithm. Okay, the third one is if log x to the base a is equal to log x to the base b, the numbers are the same, only the bases are different, then you can say that a is equal to b. So let's see how we can use this concept to solve logarithm equation. So case 1, logarithm equation leading to linear or quadratic. Find x if log 32 to the base a is equal to 5. Now this, by definition, you can say that 32 is equal to a to the power 5. This implies that 32 can be written as 2 raised to the power 5 equal to a to the power 5. And then the exponents are the same. So we can say a is equal to. Or if you want to use the second concept by expressing both sides as a single log, then this, we have log to the base a 32, then we express this one as a log, and then the base is a, so we can say that 5 log a to the base a. We have not changed anything because this is 1. And then we have log to the base a 32 is equal to log to the base a to the power 5. So this implies that log, because both sides have been expressed as a single base, so you can say that 32 is equal to a to the power 5. 2 raised to the power 5 is equal to a to the power 5. Therefore, you can use this or that. The second one, solve the equation this. So by definition, you can say that 2x plus 1 will be equal to 2 to the power 3 by definition. And this implies that 2x plus 1 is equal to 2 to the power 3 is, so we have 2x will be 8 minus 1. Understand this? So 2x will be equal to 7. So 2x on 2 equal to 7 on 2. 2. So x is 7 on 2. Or 3 whole number 1 on 2. Yes, you can use the second method. Express this one as a single log, and then we take antilog on both sides. Let's look at another example. Find the true set of this. Here the base is 2. There are two ways. Either you express the left hand side as a single log, and then the right hand side is just a number, then you use the definition. Or you express the right hand side as a single log, and then you take antilog. This implies that On the left hand side, this is plus. So we have log to the base 2 x minus 3 times x is equal to 2. So by definition of log, x into bracket x minus 3 will be equal to 2 raised to the power 2. So x squared minus 3x will be equal to 4. Now this is quadratic, so x squared minus 3x, let's bring the 4 to the left hand side, minus 4 is equal to 0. Now how do we solve this? We find the factors of minus 4. Two of them, when you add you get minus 3, when you multiply you get minus 4. So the factors will be minus 4 and 1. So x squared minus 4x plus x minus 4 is equal to 0. So x into bracket x minus 4 plus 1 x minus 4 is equal to, which implies that x minus 4 in one bracket, x plus 1 in another bracket is equal to 0. And now this is the same as x minus 4 is equal to 0 or x plus 1 is equal to 0. So this, you send 4 to this side. So we have x is equal to 4 or x is equal to minus 1. Now remember, x is greater than 0. Yes, we don't have log of 2 minus log. So x will be equal to 4. So in this case, only 4 will satisfy the equation. Therefore, the truth set x such that x is equal to 4. Look at another one. So bracket open log n to the base 2 all raised to the power 2 plus log n cube to the base 2 is equal to 10. Now the care must be taken when you are solving such an equation. Good. So we can write this as log to the base 2 n all squared plus 3 log n to the base 2 is equal to 10. So look at something. We have log n to the base 2 and then log n to the base 2. We can make substitution. So let m be equal to log n to the base 2. So this implies that, so we have m squared plus 3m minus, let's bring the 10 to this side, 10 is equal to 0. This is quadratic. We need to find m. So 1 times minus 10, which is minus 10, and factors of 10. Two of them, when you add you get plus 3, and then when you multiply you get minus 10. So we can try 2 and then minus 2 and then 5. Minus 2 plus 5 is plus 3. Minus 2 times 5 is minus 10. Then we break the middle term into these two factors. So this implies that m squared minus 2m plus 5m minus 10 is equal to 0. So we have m into bracket m minus 2 plus 5 into bracket m minus 2 is equal to 0. So we have m minus 2 and then m plus 5 is equal to 0. And this is m minus 2 is equal to 0 or m plus 5 is equal to 0. With this, m is equal to 2 or m is equal to minus 5. Remember, we were told to find n, not m. But we said that m is log n to the base 2. For m is equal to 2, we have log n to the base 2 is equal to 2. So by definition, n will be 2 with the power 2, which is 4. And then for m is equal to minus 5, So log n to the base 2 will be minus 5. So n will be equal to 2 to the power minus 5. So which is 1 on 2 to the power 5, which is equal to 32. So therefore n is equal to 4, 1. Viewers, thank you very much for watching this video. If you are watching me for the first time, I will urge you to click on the subscribe button, and then you can also turn on your notification button so that anytime I post a video, you'll be alerted.